A very good afternoon. Punjab Agriculture University feels honored to host this, the Nobel Prize Series 2019 in the campus of Punjab Agriculture University, Ludhiana. I request to start this session, please rise on your seats for the Invocation Song. I request everybody to please rise on the seats for the Invocation Song.
शिवावर मोहे है शुभ कर मन ते कबहू न डरो शुभ कर मन ते कबहू न डरो अरसो जब जाए लड़ो निश्चय कर अपनी जीत करो निश्चय कर अपनी जीत करो पर सिख हो अपने ही मन को ए लालच हो गुण तो उतरो लालच हो गुण तो उतरो जब आग की औद निदान बने अत हिरण में तब जूझ मरो अत हिरण में तब जूझ मरो देह शिवा पर मोह है शुभ कर मन ते कबहू न डरो शुभ कर मन ते कबहू न डरो
To start with the invocation, we request the Almighty to bless us with the strength to deliver our noble duties. The Punjab Agriculture University is hosting this Nobel Prize Series 2019 in collaboration with the Department of Biotechnology, Government of India, Punjab Government, Dr. G.S. Khus Foundation, and also in the partnership with the Nobel Foundation. We are organizing this event in the campus of Punjab Agriculture University, Ludhiana. We are really honored to have with us the Nobel laureates with us for this series. Today we will be having two sessions, parallel session afternoon, and two presentations we will be having on the stage right in this session also. We are honored to share with you that we have very elaborative, decorative gathering of scientists, students from different institutes, medical institutes, engineering institutes, universities of basic and sciences, then definitely agriculture and veterinary sciences institutes, and above all, the next generation scientists from the schools. We have very good participation from the schools. Let us clap the young chaps of students from schools we have with us. Today we have two Nobel laureates. You will be getting the details in the later session. Then we have Professor Serge Horoshe. Let us clap for Nobel laureate Professor Julian Serrat. Now I request the Vice Chancellor, Punjab Agriculture University, Ludhiana, Dr. B.S. Dhillon, please come on the stage and welcome you all and brief about the event. Dr. Dhillon, please.
Good day, Sat Sri Akal, Namaskar. Very warm welcome, though it's very warm outside. Very warm welcome to all of you to this Teaching and Learning Nobel Prize Series, India 2019. But first of all, I must say that we are sorry that we are a little late due to various reasons. It is a red letter day in the history of university. A number of renowned scientists have visited this university. These include, I will say, large majority of the World Food Prize winners, which we consider as the highest among various prizes in food and agriculture. I would not name these. A large number of food prize winners. But only one Nobel laureate Dr. Norman Borlaug, who got Nobel Peace Prize, he has been visiting us, though repeatedly. And today the university is crossing the barrier of food and agriculture. It's a matter of great pride that we have great scientists, Nobel laureate and others from the other fields. So it is my matter of great pride and privilege. In fact, I wanted to search for latter word. This is in normal routine pride and privilege. Professor Horish, I could not find better word than that. So it is a pride, privilege, honor for me, for PAU, to welcome Nobel laureate in physics, Professor Serg Harosh. Then member of the Nobel Assembly, I will come to that later on, Professor Julian Serrat, Laura Spreckman, and other members of the Nobel Prize series and Nobel media. We also have with us, we are honored by the presence of Mr. Klaus Molin, His Excellency, the Ambassador of Sweden to India. Also with us are Dr. Renusrup, Secretary DBT, Muhammad Aslam, Advisor DBT, Dr. T.R. Sharma, Nabi, Dr. A.K. Joshi, Dr. M.S. Kang, Dr. A.S. Nanda, and colleagues from state government. Welcome. I welcome them all. It's a matter of great pride to welcome students from schools, including those located in rural areas, students and scholars from medical engineering, agriculture, veterinary, other streams, faculty of various institutes. For the information of those coming from outside, we normally host, I will say 95% of the assemblies are from agriculture or of the farmers. I think this is one of the rare occasions when we have such a large gathering from other stream also. So thanks to the Nobel Assembly, Nobel media, that they gave us this opportunity. We are privileged to be host of this event, teaching and learning in the Nobel Prize series, and having unique opportunity to have the student and scholar from various streams. We have two esteemed speakers. The detailed introduction will come later on. And most of you may have already read in the handouts about the illustrious career of the two persons. One is Professor Harosh. He has worked on quantum physics, and other is Professor Serrat, who worked in or is working on clinical psychology. Professor Roche's research activities have been in quantum optics and quantum information science. Most of us are not expert in this field, but understand how it provides most profound insight into the fundamental nature of reality. And I am very happy to share with you that he received 2012 Nobel Prize in Physics. I must also share that Mrs. Harosh has also honored, she is also among the audience. Professor Serrat is head of the section of integrative physiology at Karolinska Institute, Sweden, one of the world's foremost medical universities. Professor Serrat's research has provided evidence for physiological regulation of insulin signal pathways, revealing key steps that are impaired in diabetic patients. Professor Serrat, I must share with you that here in India, or this part of India, the diabetic cases are increasing day by day. She is member of Royal Swedish Academy of Sciences and member of Nobel Assembly. In Nobel Assembly, she was chair from 2013 to 2015 and is currently its member. It is the Nobel Assembly, my dear students and colleagues from various institutes. It is Nobel Assembly at Karolinska Institute that is entrusted with the awarding of Nobel Prize in Physiology Medicine. You can see how eminently placed Professor Serrat is. He is among the selectors who select the Nobel Prize winners. All of us in the audience must be greatly excited and eager to listen to the pillars, these two pillars in science. They will also welcome your questions after their addresses. It is a pleasure to welcome Dr. Renusrup, Secretary, Department of Biotechnology. It's a pleasure to welcome her on her first visit to PAU after taking over as Secretary of Government of India. She is serving and nurturing the Biotechnology Department for almost 30 years now. She is major architect on National Biotechnology Development Strategy. She is also champion of cause of women in science. The Business World magazine this year hailed her as business world's most influential women in India. Her presence adds special dimension to this gathering over here. We have DBT colleague Dr. Aslam, who is advisor in DBT. It is my privilege to extend warm welcome to him as well as to Dr. T.R. Sharma, Director, National Agri-Food Biotechnology Center at Mohali. PAU and NABI have been complementary role, and we are fortunate to have this institute in Punjab and share many collaborative efforts. I also welcome other colleagues from DBT. There are a large number of colleagues from various DBT institutes. Let me something about this event. When PAU, along with Dr. G.S. Khush, I will say most eminent rice breeder and also one of the winners of World Food Prize. He has set up foundation over here. When we sent our request to DBT and Punjab government for holding this Nobel Prize series, we were apprehensive on two accounts. One was locational disadvantage, and second was being agriculture university. Agriculture university in India are associated more with ICR. But Dr. Swaroop found out a unique way to overcome these limitations. I was just hinting when you were sitting at breakfast table, by involving Nabi, Dr. Sharma ji, in the event, in that not only PAU benefited, but the event also gained importance, much broader coverage, Nabi being at Mohali. My special thanks to Dr. Swaroop and Dr. Sharma ji. We have here Vice Chancellor of our daughter or our sister university, which is dealing with veterinary animal sciences, Dr. A.S. Nanda. He is Vice Chancellor there. He has also honored us. My predecessor, Dr. Manjeet Singh Kang, who has spent about 30 years, 40 years in the USA and then came over here to guide this, to pilot this university. He is also here. Welcome Dr. Nanda and Dr. Kang. And also I welcome Dr. Joshi, who is Director BISA. BISA is Borlaug Institute for South Asia. I want to acknowledge Professor May-Britt Moser also, who will be joining us on Skype. Professor Moser is working at Norwegian University of Science and Technology. She discovered grid cells and identified head direction cells, conjunctive cells, and border cells in the brain. She received a 2014 Nobel Prize in medicine. So we have the honor of we will be listening to scientists over here, and third, Professor Moser will be interacting on Skype. I heartily welcome students, scientists, doctors, teachers, policymakers, academicians from different parts of the state, and sincerely hope that today interaction will not only inspire engagement with specific temperament, with scientific temperament, but also help us to ignite innovation and creative thinking, which is very, very important, which we must do among the students. And dear students, it is all for you, it is due to you, it is for you, it is by you. And I am very thankful to those who came here before 9 when I came just over here. Some students are standing in the queue. Today is the IT revolution. It has deluged our academic world by a flood of information. This is now making us look at the role of teacher in the new light of. Thus the theme, teaching and learning, chosen by Nobel World Series, is very timely. And today we have today's engagement that acquires an altogether new meaning in the light of these developments. Besides the content, teacher is a role model and source of inspiration. We, the teachers, have a challenge of raising a generation of young men and women who have to know and do a lot more than us. They have to exceed and supersede us in all quarters. Our challenge is responsibility. Our challenge and responsibility is how to take them to this path. I normally say in one word, the first PhD who got PhD, his advisor must have been MSc. That is simply that student have to be better than the teacher. Newer generation have to be better than us. May the lecture and deliberations today provide the insight and inspiration we need. Now, in today's world, it is getting increasingly stressed by anthropological activities, and sustainability issues have become too vital. Professor Harosh was discussing again at the dining table about this. There are many issues, and among those issues, food security comes on the top. Other things come later. And much of this university current research focus is on this ideal, that is sustainable development of agriculture. The university is known for Green Revolution and played a major role. The colleagues who have traveled from Chandigarh, from Mohali, they must have seen agricultural beauty on the way. In Western Europe, we see natural beauty, but here you see two crops, rice and wheat, two different seasons. So we are known for Green Revolution and played a major role in national food security for several decades, and now seeking to lead in natural resource conservation and precision agriculture. The university is developing and integrating scientific and technological developments into practice, which are eventually being taken to the farmers. We organize 2 times, because we have 2 crop seasons, 2 times farmer fair, and more than 200,000 farmers visit every 6 months, besides those visiting every day in these farmer fairs. We organize at 7 places in the state. A small exhibition, dear students, a small exhibition related to application of science and agriculture has been put up upstairs. I am sorry we could not arrange it downstairs at this venue. I request you to please visit and provide us your kind input. Again, yesterday an exhibition on Nobel Prize media was inaugurated at Nabi at Mohali. It will be open for at least 1 month, maybe for more than 1 month. I encourage you to visit exhibition. If needed by the schools, if they get in touch with Director such, Dr. Navtesh Singh Bains, please get in touch with us. We will provide transport from Ludhiana, and if need be from other places. Also, we have district extensions services in almost every district. I think we can provide from other places also, but definitely from Ludhiana, you are all welcome. Please take advantage of that exhibition. I once again welcome you all. Thank you very much for coming of far off places. Jai Hind. Thanks.
Thanks a lot, Dr. Baldev Singh Dhillon, Vice Chancellor of Punjab Agriculture University, for sharing his views on this event. We are thankful to Department of Biotechnology, Government of India, who has extended this opportunity to host this event at PAU Ludhiana. So I request and invite the Honorable Secretary, Department of Biotechnology, Government of India, Dr. Renu Swarup, please come on the stage and share her views on this series and the event. Dr. Renu Swarup, please.
Very good afternoon to all of you. It indeed is a pleasure to be here and, as Dr. Khush said, see an auditorium full of young students, researchers and faculty. I think that says it all. The excitement that is there amongst them to welcome our Nobel laureates, I think we all join in that excitement. But first of all, I would like to convey our deepest thanks to the Vice Chancellor for hosting this here, for giving all the students, the researchers, this opportunity to be able to interact, and most importantly, the very warm welcome that you gave to the guests as they arrived. Thank you very much, Dr. Dhillon, for this. I, on behalf of this entire audience here, on behalf of the group which has been engaged in this, I'm really once again very pleased to extend a very warm welcome to our esteemed laureates. We have with us Professor Ruche, and we, of course, Dr. Satyadri. Mr. Satyadri could not join us here, but he was there yesterday. We have with us Julian. Thank you so much for being here. And as the Vice Chancellor said, we will be having Samosa joining in on Skype, and I think that would be wonderful. I would like to thank Laura and the team from the Nobel group for taking this wonderful initiative, and I think the departments, this is the third in the series. This has been one of the excellent partnerships that we've had to be able to take to the students, to the teachers, this wonderful series. Thank you, Laura, for the entire support your team has given for this. Excellency Ambassador, thank you very much for being with us. Your presence yesterday and today clearly signifies not just your interest in this, but the deep engagement which India and Sweden and the wonderful partnership that we enjoy. We hope we can do many more such interesting things together in this partnership as we move on. My welcome and appreciation for all the senior researchers, distinguished scientists, faculty, difficult for me to name everybody, and all other senior experts who have joined in here today. We have had a very exciting beginning, and yesterday what we launched at NABI, including not only just the series but the exhibition, was so well appreciated. We had hundreds, in fact, the number went to nearly 1,700 is what Dr. Sharma was mentioning to me. Scholars, teachers, students, and they shared a very rich dialogue with the eminent laureates and with the scientists. I think continuing this dialogue here at PAU is important. And PAU, of course, we are sitting at PAU, but I think it's very important for us to recognize that it is an institution that has revolutionized agriculture and food security in India. And today, it brings to all of us here the theme of teaching and learning, and bringing this theme of teaching and learning to the heart of the institute that has continuously addressed issues that the entire globe is challenged with today. Addressing today's water, soil, agriculture, climate change challenges, while meeting with our sustainable development goals is a great task. And I think this is really what this institute has been playing a major role in, and through multidisciplinary thinking and multidisciplinary action. This is indeed one of our premier institutes, and the scientists here work so closely with the farmers, as you heard the Vice Chancellor say it, working with the social scientists, working with the civil society. And this is the new paradigm that we are looking at, these partnerships that get built. We keep talking only about the industry-academia partnership, but I think the partnerships that we build with the society, the partnerships that we build in developing this inclusive sense of taking economic and sustainable development, I think this is the partnership which is important, and this will lead to the innovative thinking that is required to make India what we see as a great destination for innovation. And what better than an agriculture university today moving its partnership beyond agriculture to look at other themes, because I think rightly said, the foundation of any sectoral area is teaching and learning. Teaching and learning is agnostic to area. It doesn't really have to be specific for agriculture or physics or any other area. It's agnostic to it. And that is the foundation on which we want our students to get the best of it, so that once we nurture them at this level, they are then going to be the leaders of our future. The largest agriculture university in Asia, set up in '62, the Punjab Agriculture University, as we know, boasts of many accomplished scientists, and to name a few, we have Dr. Gurdev Singh Khush, and we see the Khush Foundation. There are many more, and Dr. Khush being himself an agronomist, a genetist. We have your own Vice Chancellor, Dr. Dhillon, a very, very eminent scientist, and each of them has contributed to a lot of research. There is a long legacy of advancement in science which this university boasts of. Selecting PAU as a location, as very rightly said by Dr. Dhillon, was definitely important for us to see how we take this wonderful series into other cities to be able to expand the reach that we have. And identifying PAU, of course, when they were very forthcoming and wanting to be the host for it, we were so pleased to hear about it. But as I said, an institute which has been a leader in education for decades, it was definitely it took us a moment to say, yes, this is something we would love to do. And it is a pleasure that we are here today with you and your team, Dr. Dhillon, for this important dialogue. The Department of Biotechnology has had very close relationships with the Punjab Agriculture University, and over years we've collaborated in a large number of programs across different different fields, and we hope that we can continue this relationship in future. This dialogue today, as I said, is just one testimony of this partnership that we have. It's also important to see how, as I said, we just do not have the agriculture scientists working, but we see this as a growing and evolving partnership where you look at cutting-edge technologies coming in, which are moving away from the traditional and conventional techniques of agriculture, genetics. It's looking at newer techniques. We're talking about precision agriculture. We are talking about even basic research sciences. We're talking about quantum biology. We're talking of many other such fields which will have a direct and an indirect impact on the leading advancements of science. And I think that is the new spirit that we would want to bring into our students here, to look at newer areas of technology development, cutting edge areas of technology, and seeing how you integrate it seamlessly with your conventional technologies. I think it's this integration of newer technologies with the conventional ones which will then give us what we are looking at as our innovation, research, development as we move along. Yesterday, as was mentioned, we had an exciting start, and in addition to the dialogue, we had this wonderful exhibition which was inaugurated, which is for the greater benefit of humankind. And this exhibition, as the Vice-Chancellor has said, is truly an exhibition which each one must visit and see. Not only does it relate science to your daily life, but it's interactive, and I'm sure the students would find it very interesting. And I think it's that shared commitment of excellence and innovation for trying to see how we address the challenges of human well-being, which will then bring together all the researchers, the students, and the teachers. And I'm thankful that Dr. Dhillon, you have offered this arrangement to be able to take more students. I'm sure we will do that, and we will look to Dr. Sharma to see if need be, we will also consider extending the exhibition beyond the 4 weeks that it is originally planned, if we have the arrangements well worked out with the Nobel Museum. And I'm sure Ms. Erica will work with us to see how we can do that. I'm also sure that you've been quite excited with the wonderful response which even a single day of exhibition has brought in. We'll be happy to see how we can take that forward. This is the third in the series, and the last two Nobel Prize series that we held, the first one in Ahmedabad, the second one in Goa and Delhi. We've had thousands of scientists, teachers, and students who've been a part of it, and they've gone back with messages of hope and unlimited possibilities. Today at PAU, this whole dialogue has been very carefully curated, and we are sure that this will have ideas which get exchanged for, as I said, the next generation of our teachers and students. As we look at where we stand today, with the digital technology more or less overtaking all other technologies, having such dialogues where you have a one-on-one interaction with the scientists, with the experts, with your role models, those chances are getting fewer. Children get more engaged onto digital technology interactions, but you will yourself realize how much difference it makes to have a face-to-face interaction. And I'm sure for many of you, in fact, I can say clearly for most of you, this will be your first interaction with a Nobel laureate, the students especially, and I'm sure this is an opportunity which you will cherish. And as you move forward in your life, in your research, in your career, you will always look back on this day as being something which has been very important, and I'm hopeful will actually guide you in your further future career or your path as you move along. The teachers play a very, very inspiring role, and the students, as we've said, in the teaching and learning are a combination, the teachers and the students, who need to get this impact. So we're very pleased that the theme teaching and learning is actually encompassing both the key groups, the teachers and the students, as we take on. If you look at talking to the students, I'm sure this would be an opportunity for you to see how you could bring in a lot of your dreams, a lot of your expectations, a lot of vision that you've had, the aims that you've had, in which you can then try to see how you can fulfill. At this point, I would like to quote Swami Vivekananda, who had said, "There is only one difference between dream and aim. Dream requires effortless sleep, but aim requires sleepless effort." And I think you need to sleep for your dreams, but you need to really wake up to fulfill those aims. So it's a combination of your dreams and your aims. Make sure that the dreams that you have can actually get converted into a very specific aim and objective. It's that specific aim and goal which will guide you as you move through your careers. And I hope this Nobel series will actually be an inspiration for you today to take forward that particular aim that you have and develop all the wonderful ideas which many young students here, and I see them up there as well, can benefit, and try to see how you can benefit the whole of humankind. I would like to conclude here once again saying I hope you have a wonderful interactive time today. Once again, make the most of this opportunity. It's not very often that you get this opportunity of having a galaxy of scientists and Nobel laureate amongst you to be able to take advantage. And I would also once again conclude with an important teaching which our revered Rabindranath Tagore said. And he said, "The highest education is that which does not merely give us information, but it makes our life in harmony with all existence." So I think it's important to see that it's not just information that we are taking in, but it's trying to see how we bring that impact into life. And yes, dear students and teachers, I hope this will give you that inspirational insight. I hope this key learning and teaching will be an important tool which will help you to be able to realize that aim which you have of being able to be the mover. You could be actually the one who could bring in a lot of change when we look at the various challenges that we have and see how we could have science, we could have research being of great benefit to humankind. So once again, good luck to all of you. Have a wonderful time. And thank you, Dr. Dhillon, for hosting us here. Thank you very much.
We are thankful to Dr. Renu Swarup, Secretary, Department of Biotechnology, Government of India. And really it's an honor to have this series in Ludhiana. Like Madam said, the purpose of this series is to take these scientists to different cities of India. And after Ahmedabad and Goa, Ludhiana and Punjab, Chandigarh, they are the cities for 2019. Thanks a lot, ma'am. Now I request from Nobel Media, with the support and with the direction of Nobel Media, we are hosting this series. We request Ms. Laura Sparshma, who is the CEO of Nobel Media. Please come on the stage and share her views on this series.
Thank you, Dr. Renu Swarup, for your words, and thank you, Mr. Vice Chancellor from Punjab Agricultural University, and thank you all for this very warm welcoming. The flowers, the music. I even noticed a quote by Alfred Nobel in the entrance and one by Pablo Neruda, a literature laureate from 1971. So we feel very, very welcome here. Thank you so much. And it's such a pleasure to see you all students sitting in this auditorium. Professor Serge Haroche, Professor Julian Serrat, distinguished guests, Ambassador Klaus Molin, and not least, dear students. It's an honor to introduce these lectures to you, which are part, as has been mentioned, of Nobel Prize Series India 2019, which started yesterday with the inauguration on the exhibition that was mentioned by Mr. Vice Chancellor, and I can only support his words in terms of please visit it, and it's great to hear that there's transport provided, so please don't miss the opportunity. It will be there for at least a month. We had discussions and we had very inspiring talks with teachers and students. The purpose of Nobel Prize Series is to celebrate learning and education, and it's a moment for reflection, but also for inspiration and thinking about what investment it means to our lives, to dedicate time and effort to learning. And I can assure you it pays off whatever you choose. It's not only about knowledge, it's about happiness and well-being and finding a meaning in life if you find your true passion and you learn what you're really interested about. So do it for yourself and the success will come. Now it's time to introduce the two lectures. I'm not going to take any more time from the two great lectures that are waiting for us here. And I'm not going to go through the extensive curriculums of both our speakers. You're more than welcome to read them if you have not done so on our website, nobelprize.org. After each lecture, you also will have the chance of asking questions, so think about them already now. Before I conclude, I would like to thank Punjab Agriculture University once more for hosting us. Thank you so much to the Department of Biotechnology and Dr. Renu Swarup for collaborating with us. A special thanks to our Nobel International partners, 3M, ABB, Ericsson, Scania, and Volvo Cars. A special thanks to the Meta Family Foundation for this really beautiful collaboration. And many thanks to the Embassy of Sweden and Mr. Ambassador. It's a great pleasure to have this collaboration. And not least to all my dearest colleagues who have made this possible. So finally, this first lecture is by Professor Serge Haroche, Nobel laureate in physics from 2012. He's chair of quantum physics at Collège de France. And he will be speaking about how basic and applied science nurture each other. So without further ado, I warmly welcome Professor Haroche on stage. Thank you and enjoy.
We are thankful to Ms. Laura Sparsha for sharing her views on the series. So we have the first speaker for the day, Professor Haroche. Students, if I talk about myself, generally we come through the names of Nobel laureates on big books while preparing for the competitions, quiz competitions, but today we are seeing the Nobel laureate in front of us. Let us clap for the Nobel laureate. Yes, please.
Thank you very much for this warm welcome. I think it's I know it's the third time I'm coming to India to attend one of these Nobel dialogues, and each time I've been very pleased to be able to interact with so many enthusiastic teachers and students, and this time it has been very, very fruitful and very interesting yesterday in Chandigarh, and I'm looking forward to a very interesting meeting today at the PAU, at the Punjab Agricultural University. I know that you are here involved in very important applied research. Your goal, your aim is to find ways to increase the yield of agricultural crops in order to feed an increasing population, and to do it in a way which is sustainable, which means that you don't want to exhaust the planet. And so it's a big challenge, and it involves a lot of research in what is known applied physics, applied science in general. I am a specialist. I am working in basic science. and in quantum physics, and I just want to reassure you, I won't be talking about quantum physics here because it would take much more than half an hour. So what I want to do is to reflect on the connection between basic and applied sciences and show how these are two sides of the same coin. Basic science and applied science have to work together in order to be productive. When you ask yourself, why are we doing scientific research? Usually you have two kinds of answers. The first one is that you do it because you want to satisfy our curiosity. Mankind has always been curious and wanted to learn about nature, ask and answer questions. And this is often called blue sky research. And maybe one of the reasons it's called blue sky research is that it answers questions such as, why is the sky blue? Why are the clouds white? And this has to do with very basic properties of optics, of the interaction of light with matter, with molecules in air, and with droplets of water in clouds. And the first scientist which has approached this problem in a scientific way was Newton in the 17th century, who discovered that white light was a superposition of radiation of different colors, and these different colors interact differently with matter, which explain why the sky is blue and why the clouds are white. Now, there is another reason, of course, to do scientific research. It is to achieve useful tasks and fulfill societal needs, such as the tasks that you are doing here at PAU, which are, of course, very important for society. And one must say that very often politicians, especially when there are some economical problems, favor short-term usefulness, and they consider that long-term curiosity, basic science, is a kind of useless luxury, and that you have to focus on short-term results and do only applied science. And as I'm doing basic science, I advocate for basic science, and I want to show you in this talk that this view of just separating what is useful from what is useless is short-sighted. History of sciences illustrates all the time that blue sky research and technology are the two sides of the same coin, and that they cannot be separated. For instance, we all know that great scientists in the past have made tremendous advances in science. Scientists like Galileo, Newton, Maxwell, Einstein made us discover how nature works, the laws of nature. But when they did their discovery, they had absolutely no idea about what their findings could be useful for. But they have, in fact, led to innovations which have changed our lives, our ways to produce energy, our ways to improve our communication, our ways of improve our transportation, our ways to store and process information, to probe matter, to perform medical diagnosis, and so on. And these applications have emerged very often in an unexpected way from the combination of breakthroughs which are coming from different basic research areas and after a very long maturation time. And I would like to illustrate this by giving you a few examples. The first example I will take has to do with the discovery of electromagnetic waves and the discovery of the fact that light was an electromagnetic wave. This is a typically blue sky research. In the 19th century, the French physicist Ampère and the British physicist Faraday have discovered how electric currents were producing magnetic fields and how, in turn, the change of magnetic fields were producing electric currents. And Maxwell, reflecting on the work of Ampère and Faraday, wrote 4 equations which describe how electric and magnetic field propagate through space together. This is electromagnetic waves. And on the top of this slide, I show you a picture of electric and magnetic field propagating through space. They are waves which have crests. The distance between two crests is a wavelength. And Maxwell's equation showed also we're able to calculate the velocity of this electromagnetic wave, and he found that this wave propagated exactly at the velocity which had been found for light. And so Maxwell discovered that light was in fact an electromagnetic wave, but of very specific wavelengths. The wavelengths that you can see with your eye are very short wavelengths comprised between 0.4 and 0.8 micrometer. But what Maxwell predicted is that outside this very narrow window, you had long wavelengths which were invisible and unknown at that time. And on the other side of this window, you had short wavelengths which were also invisible and unknown at that time. And so this was basic research, and it led a few years later to the discovery of long wavelength radiation by the German Hertz, and 10 years later by Röntgen in Germany, the discovery of very short wavelength radiation, which he called X-rays, because at the beginning he did not know what it was about, but it was discovered that it was short wavelength electromagnetic waves. And of course, the discoveries of Hertz and Röntgen had a very big impact in applied sciences. It has led to a revolution in technology, radio broadcasting, microwave applications come from Hertz discovery, and X-ray medical diagnosis and all kind of diagnosis with X-rays came from Röntgen work. And by the way, Röntgen was the first Nobel Prize awarded. He was awarded the Nobel Prize in Physics in 1901. The first years of Nobel Prizes were distributed. So you see how basic science nurtured applied physics, applied science. But it's not the whole story. When X-rays physics and when microwave physics and when improvement in optics went on at the end of the 19th century, very small subtle effect appeared which showed that classical physics, Maxwell's equations, were not enough to understand what was going on, and this led to the revolution of relativity and quantum physics. So we went from basic science to application and then back from application to basic science. At the end of the 19th century, just in the year 1900, Lord Kelvin, who was a very great physicist in England, gave a talk at the Royal Institution in London, and the title of the talk was 19th Century Clouds over the Dynamical Theory of Heat and Light. It seems a very technical title, but what Lord Kelvin meant is that there were two questions about thermal radiation. Thermal radiation is a description of how heated objects radiate electromagnetic wave, radiate light, and another unsolved question about the velocity of light, the fact that the velocity of light seems to be the same for all observers, that you cannot catch up a beam of light. However fast you go, the light is always going at the same speed with respect to you. And this was impossible to explain by classical physics. And these two clouds led to the quantum revolution and to relativity. And in fact, there is one man who did breakthroughs in both these fields, who discovered relativity and who made great advances in quantum physics. It is, of course, Albert Einstein, who wrote in the year 1905, which is called for physics the miraculous year, 4 papers which revolutionized completely physics. And this has led to all the innovation, all the inventions, all the instruments which have changed our life in the 20th century. The same year, 1900, there was a big exhibition fair in Paris, World Fair, and at this World Fair there was a kind of contest which was started. People were asked to try to imagine what the world would be in the year 2000. So people of 1900 tried to see what would be the technologies today. And what they published in postcards is a little bit naive. You see the kind of postcard which were published at that time, and I am sure you cannot recognize in this postcard the way we are living now today. It was impossible in 1900 to predict computers, and of course computers come from quantum physics. Computers are made of transistors, and the circulation of currents inside the transistors is based on the laws of quantum physics. They could not predict lasers, and the lasers are based on the basic interaction of single atoms with single grain of light called photons, and this was also absolutely impossible to predict in 1900. They could not predict, of course, the GPS and the atomic clocks, and I will talk about this later, and they could not predict, for instance, MRI, magnetic resonance imaging, which has revolutionized the diagnosis and the research in medicine. So you see, all this has come from basic science, and this application would have been impossible without basic science research. Let's focus on the GPS. As you know, the GPS is based on the fact that you have satellites going around the Earth, a lot of satellites. Each satellite carries a very precise atomic clock. These clocks are synchronized with each other. They exchange signals to be at the same time, and they send pulses, synchronized pulses, which are detected by your GPS receiving machine, which can be now your cell phone. And from the timing of the pulses you receive from 3 or 4 satellites, by triangulation, you can find out where you are on the surface of the Earth with a precision which is of about 1 meter. So it's a fantastic feat. Everybody uses this now without asking questions, as if it was magic, but it's not magic. It's physics, and it's quantum physics, and it's relativity physics. Quantum because the atomic clocks are based on quantum laws, and relativity because you need to make corrections due to relativity if you want the system to work. In fact, what you have to take into account is that the clocks which are traveling with the satellites are beating at a different rate because they have a relative velocity with each other. And special relativity tells us that the time does not elapse at the same rate depending upon your velocity. And you have another relativity correction, which is called general relativity, which tells you that if a clock is above the ground in a different gravitational field, its rate is modified by the altitude. And you have to take these corrections into account. At the beginning, the engineers who developed the GPS system thought that these were just theoretical physics considerations, and if they did not take that into account in the software of the computers, which transforms the pulses into an indication of your position on the surface of the Earth, the result were falls by several kilometers. So you really have to take this relativistic correction into account. And we can say that millions of daily users, taxi cab drivers all over the world, are verifying the theory of relativity, of course, without knowing it and without thinking about it. What I want to say also is that the GPS is not only used to help you to find your position, the GPS makes it possible to measure the Earth's surface by triangulation with a fantastic precision. And the measurement of the shape and of the size of the Earth is a very important aspect of basic physics. We have to understand the planet on which we are living and its exact shape, and I will talk about this a little bit. In fact, you see, this is, in fact, the shape of the Earth with exaggerated features. At first approximation, the Earth is a sphere, but in fact, it's not exactly a sphere. You have some corrections which are due to the fact that different masses are distributed in inhomogeneous way, and the geoid surface, which is a surface of equal gravity, is not a perfect sphere. And ultra-precise atomic clocks, which are carried by satellite, help us determine the exact shape of the Earth. This is basic science, and it's basic science which started very, very long time ago. In the 17th century, people have started to ask themselves, is the Earth really a sphere? And there were 2 theories which were competing. On the top, you see what we call the Prolate Earth. The Earth is like an egg which is becoming narrower at the poles. And it means that 1 degree along the meridian decreases with increasing latitude. And the scientist who thought it was that way was the French royal astronomer Cassini, whom the king had asked to measure by triangulation France. And he found out that it seemed that 1 degree of latitude, 1 degree of longitude was decreasing when you went from the south to the north of France. And in fact, Cassini made very precise measurements, and when he ended these measurements, one could make a map of France, and the map was presented to the king, and it turned out that the surface, the area of the country was smaller than was being supposed before. And the king could joke, saying to Cassini, with your measurement in 1 stroke, you made my country smaller than a war. It's because the dimensions are smaller than we thought before. But then other scientists thought that the Earth was not prolate but oblate. 1 degree along the meridian should increase with increasing latitude, so the Earth should be like a squashed sphere, which is bulging at the equator. And the people who believed that were theorists. Newton and Huygens thought that for a very simple reason. If the Earth is spinning, the centrifugal force is putting away the fluid at the equator. And we knew at that time that inside there were flows, there were hydrodynamic flows, fluids inside the Earth, and so the Earth should be oblate. And they made calculations about this oblateness. And of course, there is another indication that the Earth was oblate. It was a time of a big exploration of the world, and the French scientists have been going from Paris to Cayenne, which is near the equator in South America, and they were carrying a pendulum with them, and they found that the pendulum was beating a little bit slower at the equator than in Paris, and this might be due to the fact that the point at the equator was further away from the center of the Earth. So there was these two competing theories, and to solve the question, you had to do an experiment. So in 1736, the French Academy of Sciences sent two expeditions, one at the polar circle, north of Sweden, by the way, and the other at the equinoctial line, at the equator, to measure 1 degree of latitude at 1 degree of latitude at two different latitudes, near the equator and near the pole. You see here an old map showing what happened in South America, in what is now Ecuador, north of Peru. The expedition, they made the measurement by triangulation. Triangulation is a technique which is used by the GPS. You divide the territory in triangles, and you measure the angles of all the triangles using a telescope. So you have to point your telescope to different landscape points at a distance of several kilometers. For example, the tip of a church tower, or a tree, or a rock, which is well identified. And knowing the angles, you can reconstruct the shape of the triangle. But then you have to find what is the overall size, and for that you have to measure one side of one triangle, and you have to do it on the ground. So you have to carry a stick, which is the standard of length, and carry the stick from one place to the next over 10 kilometers, and to decide what is this length. And from this length and from the angular measurement, you can reconstruct everything. And so you see that the French expedition, which was sent in Peru, started from Quito and went south, and they passed through a place near a volcano called the Cotopaxi volcano, where there was a very old mansion, which you see here the photograph of. And it turns out that, in fact, my wife and I, we visited this mansion, which is now a hotel, and you see there a commemorative plaque which is celebrating the 250th anniversary of this expedition, which was measuring the meridian there. So it was a kind of basic science done a long time ago. And when the two expeditions came back to Paris, they published the results in the proceeding of the French Academy of Sciences. So you see here the report from the Peruvian expedition, and it says in French, short report about the voyage made in Peru by the gentlemen of the Royal Academy of Sciences to measure the degree of the meridian near the equator and deduce from it the shape of the Earth. And the other expedition, which was sent to Lapland, also published the result, the shape of the Earth determined by the fellows of the Royal Academy of Sciences who have measured the degree of the meridian at the polar circle. And from these two measurements, it was deduced that the Earth is indeed oblate. Newton was right. And in fact, the value that Newton has found is very close to the experimental value. The difference of the equatorial and polar radius, the relative difference is 0.3%, 3 per 1,000. So it's a very small oblateness, but it's something significant. And so what is the connection between basic science and between this and basic and applied science? In fact, Maupertuis, in his report to the Academy, stated this sentence, which I translate in English. The Academy was split, before the measurement was done, the Academy was split on this issue, oblateness or prolateness of the Earth. Its own lights on this question have left it unable to decide. When the king expressed his will to resolve this big question, which was not one of the vain speculation whose idleness or useless subtlety sometimes keeps philosophers busy, but a question which must have real influences on astronomy and navigation. So you see, he was already conscious that you had to explain why basic science is important and why measuring the Earth was not just an useless task. I will just finish by giving another example of this connection between basic science and application, and we have to come back to Einstein. In 1916, Einstein had a very bright idea. He found out that when atom emits light, there is a process called stimulated emission, which was not known before. I have shown here the two levels of an atom, G and E. G is a ground state, and E is an excited state, which has much more energy. To go from G to E, the atom can absorb one quantum of light, which is called a photon, so they get excited. Once they are excited, they can fall down to the ground state by emitting one photon. This is called spontaneous emission. This photon is random. It can go out in any direction. And using only these two processes, Einstein realized that it was not enough to understand how atoms got in equilibrium with light, the problem of thermal radiation that I was mentioning at the beginning of my talk. And he had to introduce for that another process, which he called stimulated emission, by which an excited atom receiving a photon duplicates this photon, emit another photon in a non-random way, in a deterministic way, in the same mode, with the same frequency, in the same direction as the first one. And this process, which amplifies radiation, is a basic phenomenon which gave rise to the laser. So it took something like 44 years to build the first laser. For that, you have to put atoms between mirrors. You have to excite the atoms with a side excitation, which can be a discharge, an electric discharge, or a side excitation with light. And by stimulated emission, the light which goes back and forth between the mirrors gets amplified. And if one mirror is slightly transparent, the beam is getting out, and you get the laser beam, which has completely properties which are completely different from usual light from the sun or from a lamp. And I just emphasize the fact that it took 44 years between the basic idea and the application, which is the laser. I don't have time to talk about the laser very much, but I just want to tell you that it's a fantastic source of light. Nobody had thought about that before. It's a light beam which can be very intense, which can be, if you focus it on a piece of matter, you can evaporate the matter, reach huge, very high temperature. And at the same time, if you use it properly, you can use this laser light to cool matter at exceedingly low temperatures, reach the lowest temperature ever achieved in the universe. And this brings matter to new states, which I've been studying now for more than 20 years. I summarize this, the research has given rise to maybe 10 to 20 Nobel Prizes. On the other hand, this laser light is very stable in frequency and in wavelengths, and this also led to application for building new kind of atomic clocks, new kind, and doing other kind of research. And here again, the coherence and the monochromaticity of laser light has been made possible, inventions which have also triggered 10 or 20 Nobel Prizes. So altogether in physics and chemistry, there have been something like 30 Nobel Prizes delivered to laser physics over the last 50 years. So it's a very flexible tool for fundamental research in physics, in chemistry, in biology, and for applications to metrology, medicine, communication, and so on. I just want to, on the last slide, to focus on one result which has been the topic of the Nobel Prize in Physics in 2017, which is the discovery of gravitational waves. You know, according to the general theory of relativity, gravitation is in fact a curvature of space-time. If you have masses in the universe, these masses change the geometry of space and curve space, and the other masses which get around the first masses are taking nonlinear trajectories because they experience a curved space-time. This was predicted by Einstein, and Einstein also predicted that big masses, if big masses collapse in the universe, this gives rise to a ripple across space-time, which is called the gravitational wave, which spreads out at the velocity of light. And in order to detect these waves, you have to be able to measure very, very small differences in distances in two orthogonal directions, because when this gravitational wave passes, it shrinks the dimension in one direction and it enhances the dimension in the orthogonal direction. And to do that, American and European physicists have built what is called gravitational wave antennas. These are very long tubes, several kilometer long tubes, in which very stable laser beam is circulating. The beam is split into two beams going in the two orthogonal directions. It's reflected back by mirrors, and it interferes back on the beam splitter, which has produced the two beams. And by looking at the light which is coming back, it is possible by interferometry to measure very, very small imbalance between the two distances. I don't have time to enter into details, but it's a tour de force. In fact, this is called the Michelson interferometer. You need ultra-stable laser light, very powerful, and you have to be able to measure a difference in distance which is only 1/1000th of the size of a single atom, something which is 18 orders of magnitude smaller than 1 meter, and which is something like 20 or 21 orders of magnitude smaller than the distance between the mirrors. And to achieve that, you need really to have fantastic lasers and a fantastic stability to avoid all the vibration of the system. And in 2015, the first gravitational wave was detected, which came from the collapse of two black holes several billion years away from us. And so the gravitational wave took more than 1 billion years to reach us. It has this fantastically small effect which was detected, and this opens a new window to the universe. Before that, we detected only light. Now we can detect gravitational waves, and it gives other information which are very important for cosmology. So let me conclude by trying to figure out a little bit better the connection between blue sky research and innovation in physics. Everything starts from the observation of nature. From this, you build theoretical models. For instance, from the fact that light obeyed strange law for the thermal radiation, quantum physics was developed. Then these theoretical models predict new effects, stimulated emission. From these new effects, you build new technology, the laser. And the laser allows you to probe with more precision the laws of nature. So it's a kind of closed circle. And in between, of course, all these novel technologies can be very useful in applied science. So it's what I call a virtuous loop, the virtuous loop which connects basic science to applied science. And now on the last transparency, I would like to reflect on something else which I think is very important. Useless science, which I call it useless, quote unquote, which is a science which is basic, which is blue sky research, is not only useful because it will lead to application, it's also useful because it conveys the values of truth in a world where science is under attack and truth is no longer accepted by everyone. So first of all, I think that beyond its practical usefulness, basic science is a triumph of rational thinking, because you see, you go from the observation of facts, and facts cannot be faked. You know, if you say that this planet is at this position tonight, you cannot lie, because everybody can observe and decide whether you are right or not. And basic science is about stating facts which cannot be denied. And this is very important. Observation and exploration deals with real fact, not with alternative facts or fake news. Facts are explained by theories. The theory should explain the fact and predict new facts which are not yet been observed. And the theories are very different from dogmas or revelations due to religion or ideologies and so on. Theories are permanently confronted to new observations and to possible revisions. For instance, if we had not observed gravitational waves, people would have started to ask whether general relativity was right or not. So it's you have to doubt before you confirm or find that a theory should be modified. This is a rational doubt, and it's very different from mistrust, which is based on conspiracy theories. So people often say, okay, it's good to doubt. It's good to doubt if you make the right kind of doubt. If you try to challenge theories by observation, and not if you just challenge theory by opposing a theory to an opinion. Science is also very important because it is universal and provides a link between peoples and cultures. And we are an example of that here. In India or in Europe or anywhere, we all agree that science has to proceed in the same way, from observation to theory and back to observation. And this unites all of us in the same rational way of thinking. Science is also important because it dissipates illusions and prejudices and discloses a truth which is deeper than the often deceptive, obvious knowledge. And I will give you a few examples. Up to the 16th century, it seemed obvious that the sun was going around the earth. After all, you all see the sun rising the east and going to the west during one day. So it was clear that we were motionless, whatever it means, and the sun was going around us. And Copernicus was the first one to show that this was an illusion. In fact, we are going around the sun, and the sun is not motionless. Another illusion is the illusion that Einstein debunked. It was also clear for everyone that the time is something universal. My watch, your watch, all the watches give the same time if they are well conceived, well built. And Einstein said, no, it's not true, because this happens to look like that because we don't move fast enough. If you move fast enough, then the time will tick at a different rate, and this has been shown to be the right thing. And again, the fact also that the time depends upon the gravitational field, upon the fact that the universe is not flat but curved, is something which goes against illusions. And so science is always trying to fight illusions, to find a deeper truth, which is not directly accessible to our eyes and our minds. And I must say that this kind of illusions are the ones which are feeding conspiracy theories. People who say the earth is flat and we are told that it is round because it's a conspiracy are people who have not understood that science discovers things which do not meet directly the eye. This is true in physics, but it's also true in biology. Darwinian theory of evolution is not accepted by creationists because they don't have the perception that things can change over billions of years in a way which is just triggered by chance and by the pressure of evolution. So again, in physics, in biology, in chemistry, in all kinds of sciences, you have people who resist the truth because they are willingly or unwillingly going in the direction of these illusions. So I just think that training young minds to understand the quest for useless knowledge is essential, not only for scientists, it's essential to form citizens which will be, by rational thinking, able to make the difference between truth and lies. And I think this is fundamental for science, but it's also fundamental for democracy. Citizens have to be able to distinguish between statesmen who tells them the truth, even if the truth is hard to accept, rather than demagogues which are telling them false things just for their profit. So I stop here and thank you for your attention.
Thank you very much, Professor Aroche, for this very inspiring lecture and which made us learn a lot and think. So I would like to open the floor for questions. Are there any mics around or yes? Okay, perfect. Please raise your hands then if you have a question up here in the front. I see a hand. Do we have anybody with a mic? Oh, there's, okay, then you can start in the back and then the mic will come to you.
A very good morning, sir. It's an honor to interact with you over here. I'm a grade 12 student and I've been fascinated with the quantum mechanics since a long time. And whenever I go on the internet, there are so many interpretations to quantum mechanics that instead of answering a question, it raises more doubts. So according to you, how do you interpret quantum mechanics? And also, do you feel that wave function is a reality or not? Because that's really a big doubt in my mind.
Okay, this is a very deep and deep question. This explains why I did not talk about quantum physics in this talk, because it would take a very long time to answer it in details. Quantum physics is also an example of a theory which goes against illusions, against the common wisdom. The common wisdom tells us, for example, that a particle has to have a well-defined trajectory, that the particle which is going, which has a history, will go along a trajectory that you could compute. Quantum physics tells us it's not the case. In fact, what happens is that there is only a probability for the particle to be at one point or the other, and before you make the measurement, you cannot tell where it is. It has no meaning. The position of the particle appears when you perform a measurement and depends upon the kind of measurement that you are doing. This kind of non-deterministic behavior, the fact that a system cannot be described before you know exactly how you interact with it using an apparatus to make a measurement, this is something which displeased, which Einstein did not like at all. So you see that illusions, the fact that you have a bias due to your previous knowledge, is something that even great scientists cannot escape. In fact, during the last part of his life, Einstein tried to disprove quantum mechanics, and he was not able to do it. So one could say that the first part of Einstein's life was incredibly productive, but the last part of his life was not, because he had tried to disprove a theory which is now which we now find by all kinds of experiments is the truth. So in quantum physics, the wave function that you mentioned is just like an identity card, which allows you to compute what would be the probability to get such and such a result if you perform the measurement. So it's not a real object. It's just a mathematical construct which allows you to predict the probability of result of measurement. And this is something which we have to live with. Many people have tried to give an interpretation which is closer to our classical view of the world, but no one has really succeeded in a way which is satisfying. So we have to accept these rules which work. It does not mean that one day we will not be able to go beyond that. This is the way science works. As long as there is no experiment to contradict the theory has to be accepted. Maybe one day there will be a theory which will be wider, which will include quantum mechanics as an approximation, but nobody knows what will happen.
Thank you, sir.
So we take two more questions, not more unfortunately, because we're running a bit short on time. We have a hand here, and then the last one is the gentleman here in the front who has been raising his hand.
Mehdi Professor, so my question stands basically on a spiritual grounds. Like for example, could the phenomenon of astral projection be the result of quantum entanglement?
What was the question about entanglement?
Like, could be the phenomenon of astral projections be the result of quantum entanglement?
Quantum entanglement is an aspect of quantum physics which tells us when two quantum systems have interacted, even when they are separated after that by a large distance, they keep a kind of influence on each other. Any measurement you perform on the first one has an effect on the probability of results on the other part. So this is a kind of what Einstein called a spooky action at a distance, and he did not like that. But this entanglement is employed for practical application in communication, for instance. It does not mean that you can communicate faster than light, but it gives ways to communicate in secret ways, in a way that nobody can spy upon. But I didn't understand what was your specific question. What kind of thing?
Like, for example, like what I have been understood by this far, like quantum mechanics describes the vibrations of subatomic and atomic levels.
Yes.
So could the phenomenon of spiritual, astral projection be the result of this quantum entanglements?
No, I think it's the other way around. The laws of quantum physics explain that entanglement exists, but what happens inside an atom It's of course consistent with entanglement because it's the same laws of physics, but entanglement is really useful when it deals with systems which have been separated by a large distance. And it's something which could be used for communication or as a way to operate quantum computers, for instance.
Merci.
All right, thank you.
Thank
Last
you.
question here in the front.
You touched only the basic science, useless science, and the useful science,
Yes.
and did not touch your field of work, the quantum
Yes.
area, quantum electrodynamics, and the photons, and all that which these students were talking about.
Yes.
I would like to draw your attention to both of these areas. First of these is we are moving from useless to the useful. From the useless science, which is called useless or the theoretical science, to the applied science, and making use of it for the benefit of the society generally. But can we go back the other way around, from the useful to the useless,
Yeah.
to search out certain areas, to integrate them,
Okay.
to integrate them to solve our problems? Say Alzheimer's is there, say AIDS is there, so many things are there. Many problems are being faced by her. This is one question.
Oh,
Second-
I'm sorry. Let's keep it to one because we're really running short of time. It may take some time to answer it.
Just a moment, just one only, one sentence only. And this is the second part is regarding the quantum consciousness, the indeterminacy and the moving beyond the rational and the determinate. That's the major area of the Newtonian physics and this new physics, quantum physics. The two areas are there.
Okay, I
Yes,
understand.
I want to see where we stand regarding consciousness.
Okay.
This is the only point of question.
Okay.
Thank
So
you.
the first part of the question, now I forgot what was the question. No, what I want to say is that when I said useful and useless, it was a kind of provocation. What I wanted really to convey is that there is no useless science, because you don't know what will be useful in the future. And about the physics that I'm doing, quantum information, a lot of people say this will lead to the quantum computer. My feeling is that these people are doing the same mistake as the people at the 1900 who tried to project what would happen 50 or 100 years from now. We don't know. What I am sure of is that there will be applications, and maybe this application will surprise us more than a quantum computer. Now, the second question is about quantum physics related to consciousness. This is a thing which is rather typical of trying to connect fields which, in my view, have no connection. Quantum physics is undeterministic in the quantum world for small quantum system. What happens in our brain is something which happens at high temperature, at room temperature, and at this level, quantum phenomena are very difficult to see because of the coherence, the fact that the quantumness is lost in systems which are hot and humid. In fact, all the experiments we do, we try to avoid high temperature. We go to very low temperature to get quantum effect like superconductivity. So I think people who say that there are quantum effects in the brain are not giving any proof of what they are saying. And even quantum biology, which is now a field which is being developed, is very controversial because there is no direct evidence by clean experiments that quantum effects are important for biological processes. Of course, everything is quantum. The molecules are built on quantum physics, so the DNA molecule, the links between the atoms and DNA molecule are quantum links. But the behavior of the system can be described classically, and I think the biologists are working under this assumption up to now. So maybe one day we'll find quantum effects in biology, but for the time being, it's not clear.
Thank you, and
Ma'am?
thank you all for
Excuse me,
your
sir.
questions. I'm sorry. If we have time in the end, we can add another question. But please join me in giving a warm hand to Professor Haroche. It's a pleasure to welcome on stage Professor Julian Serrat, who is a professor in clinical integrative physiology at the Karolinska Institute in Stockholm. As you heard before, she's also a member and a former chair of the Nobel Committee that selects the Nobel Prize in Physiology or Medicine each year. Actually, the announcement is coming up pretty soon, on October 7th. So you will soon, or we will soon know who the new laureates are for this year. Well, we don't know if it's one or many. And so what happens up until that point? So how is the process, and how do we end up with the laureates we end up with? To hear more about this, I invite Professor Julian Serrat. Thank you so much.
All right, I've been really looking forward to this, to meet all the students and see this fabulous campus, so this is going to be a lot of fun. So over the next half an hour, what I want to do is to share with you a little bit about who was Alfred Nobel, and then I want to talk about the prizes in general, and then what I'll do is give you some insight from what I say are reflections from behind the closed doors. And keep in mind that there's very little we can say about the process of selecting Nobel laureates, but I'll share what I can. All right, so who was Alfred Nobel? Well, he was a really remarkable man. He was a chemist, an inventor, an idealist, and he traveled the world extensively. And partly why he did was because he was the inventor of dynamite, and he had factories around the world to manufacture dynamite. You can't imagine that it would be so easy to transport dynamite, so it needed to be made on site. And this allowed him to visit the world. He was considered the richest vagabond in Europe, and he lived in multiple places: Russia, Sweden, France, and Italy. And because of that, he spoke 5 languages. So he was a misanthropist, and partly that was influenced by his family dynamics. So his younger brother, Emil Nobel, dies at the age of 21 in a nitroglycerin explosion. So you can imagine he was involved with helping make the nitroglycerin. And that affected Nobel. And later, in 1888, another brother, Ludwig Nobel, dies. And this probably affected Nobel even more, because when Ludwig died, an obituary was written, and the obituary stated that the merchant of death is dead, incorrectly assuming that Ludwig was Alfred. So when Alfred read the obituary, the news was, Alfred Nobel has died. The merchant of death is dead. And Alfred stood back from that and didn't want that to be his legacy. He didn't want his legacy to be that of one of the merchant of death. In other words, making of the manufacturing of dynamite could potentially be used for very positive things, but also deleterious things. So I think that affected Nobel, and thought about what kind of legacy did he want to leave behind. Now, he was a bachelor, had no children, but yet he was one of the richest men in the world. So December 10th, 1896, Nobel dies in San Remo, Italy. And incidentally, that's the same day that the Nobel Prizes are awarded. But when he died, his secretary gathered up his stocks and his bonds and all of his documents and carried them up to Stockholm. The reason is that his last will and testimony was a big surprise to his relatives. So upon reading the will, it stated, and this is an excerpt that has been translated from the Swedish version, the whole of my remaining realizable estate shall be dealt with in the following way. So Nobel was very clear on what he wanted. The capital invested into safe securities by my executors shall constitute a fund, and the interest of which shall be annually distributed in the form of prizes to those during the preceding year shall have conferred the greatest benefit on humankind. So he was very clear that he wanted to establish prizes, and he wanted that to be for discoveries that affected the benefit of humankind within the preceding year, and I'll get back to that later. And he outlined specifically 5 areas that he wanted to award. And the first was physics, the second chemistry, the third physiology or medicine, fourth was literature, and the fifth was peace. And all of these aspects were really near and dear to Nobel's heart. I mentioned he was an inventor, he developed dynamite, so he was interested in physics and chemistry. He also had an interest in physiology or medicine, and I'll share some anecdotes about that. Literature was important to him because he was interested in writing. He even wrote some plays. And I think peace was important because he realized the potential of destruction with dynamite and wanted to ensure that people had a consciousness about peace and humankind. So the medical coupling probably comes because of a friendship Alfred Nobel had with Jens Johansson. And he was a physician from the Karolinska Institutet and a personal friend of Nobel. And this sort of highlights the idea of how important it is to have friends. So Johansson and Nobel spent some time thinking about medicine, and Nobel even dabbled in research into blood typing. So he had multiple interests. Again, I might have mentioned, but he was a real Renaissance man. So after Nobel's death, it actually took 5 years before the first Nobel Prize was awarded. And one can just ask why. Well, it took some time to sort out the estate. It took some time to establish the Nobel Foundation. One is probably not surprised that there were family protests. You know, his family, they weren't so happy about the fact that his estate was going to be cast away in prizes. A lawsuit came about. The Swedish royalties had some protests. Nobel specifically stated in his will that it should be awarded irrespective of nationality. There was a thought that this was unpatriotic. Foreigners might receive a prize. The prize awarding institutes were also hesitant. Even the Karolinska Institute, should we be burdened with handing out these prizes? We've got more important work to do. It took some time, but, well, we're all pleased to see that it did get sorted out. Let me tell you a little bit about the lawsuit I mentioned. Again, this was heavily contested. Nobel had lived and died in Italy. Many other countries were expecting that they should be able to have some decision over his will and testament. So it turns out that a man's home is where his carriage is. And because Nobel had his carriage and horses in Sweden, the will was held up, and because of that, the Nobel Prize is awarded from Sweden, thanks to his carriage. All right, let me tell you about the prizes. These prizes, again, as specified very clearly by Nobel, at least in the sciences, are awarded for discoveries, and they shall have conferred the greatest benefit on humankind. They cannot be awarded for leadership in a field of science. It's not a lifetime achievement award. In fact, the Nobel Prize may be awarded for a discovery that's published in only one paper. So you could do one experiment in your life, and that might be sufficient for a Nobel Prize if it is a great discovery. Each of the prizes have sort of a little bit more specificity behind what they're awarded for, and this is what all of the committees pay a lot of attention to. The Physics Prize is awarded for a discovery or an invention. Chemistry, a discovery or an improvement. Physiology or medicine, the committee for which I'm a member, has a very narrow remit. It is only a discovery that we can award. Literature is awarded for the most important work in the idealistic style. And peace is awarded for peace efforts, peace including conference and disarmament. So he was very clear about what these prizes should be awarded for. And oftentimes people are confused about that. Well, you know, I've worked really hard, I've contributed to the literature, shouldn't that be enough for a Nobel Prize? No, it should be a discovery, and a discovery of a great height. Oftentimes the discoveries are a completely new paradigm, a new way of looking at something, or a discovery might be paradigm shifting. It completely revolutionizes and changes the way we think about a problem. The committees, when evaluating candidates, think about, well, if we took away that individual, if we deleted them, or if we deleted that knowledge, where would we be today? So it's a deletion test. It should be so critical that if we didn't know that, we would actually be lacking something. Another prize has come on the scene, and this is the Sweden's Riksbank Prize in Economic Sciences that is awarded in memory of Alfred Nobel. And that was not originally specified in Nobel's will, but it's been awarded ever since 1969, and it's based on a donation to the Nobel Foundation from the Swedish Federal Reserve on the occasion of the bank's 300th anniversary. So that is really the additional prize that's awarded. All right, every one of these prizes has the added height of being awarded for the greatest benefit to humankind. And I think that Professor Hosch mentioned quite nicely today about how all of knowledge, basic knowledge, has a great benefit to humankind. Even if one doesn't think that basic science might affect humankind, he showed us elegantly today that many of these basic discoveries affect the way in which we see our world. All right, so where are the different prizes awarded from and why? So in Stockholm, the prize for physics, chemistry, physiology or medicine, literature, and economics are awarded. And the Peace Prize is awarded from Norway. And that was because when Nobel wrote his will, Sweden and Norway formed a union. And I think that was a great way for him to show sort of brotherhood to our neighboring country. Nobel was also very clear about which awarding institutes should handle these prizes. So physics, chemistry, and economics are all awarded through the Royal Swedish Academy of Sciences. And the different classes handle these prizes. So the physics class does the work for the physics prize, chemistry class for the chemistry prize, and economics obviously for economics prize. And what they do is they then put forward a nomination where the entire Royal Swedish Academy will vote. The prize for physiology or medicine is awarded through the Karolinska Institute, the Nobel Assembly at Karolinska Institutet. Literature is awarded by the Swedish Academy, and I mentioned earlier the Peace Prize is awarded from a committee elected by the Norwegian Parliament. And below here, if you can see them, are some photographs of the environments for which these different committee members are meeting. All right, so I'm going to spend more of my time talking about the Medicine Prize, because I have been since 2006 a member of the Nobel Assembly at Karolinska Institute and a member of the Nobel Committee for the last decade or so. So that's the one area where I think I have some inside knowledge, and I'm not able to really comment on the workings of the other committees. But as stipulated in Nobel's will, Karolinska Institutet became the academic home of the Nobel Prize in Physiology or Medicine. And at the time, Karolinska Institute was a school of army surgeons, but it's a medical university, so it's not a comprehensive university, but it's a medical faculty where we have, in addition to training physicians, we have dentistry, physical therapy, health sciences. And it was evolved from a war where Cholera led to a royal decree to establish a college for the corps of field surgeons. Many of the Swedish soldiers were dying because of infections. And the name Karolinska stems from the name of the soldiers of the Swedish army. All right, so how does then one get from Alfred Nobel's legacy to awarding prizes? And this is Carol Greider, who received the Nobel Prize from the hand of the Swedish king, Gustav, on December 10th, the day that Nobel died, on 2009. How do the committees actually work? So now I can tell you some of our secrets. So the Nobel Assembly and Nobel Committee meet at this building called the Nobel Forum, and that is really the only activities that go on in that building. And the Nobel Assembly is consisting of 50 professors at the Karolinska Institute, and this is because at the time when Nobel formulated his will, all professors of the university were in the jury for this Nobel Prize. But we have a very open society in Sweden, and in publicly funded institutions, any citizen can ask for documentation. And it would really be devastating to the secrecy of Nobel Prize work if we were demanded to release all of our materials. So we formed what we call a Nobel Assembly, and that allows us to retain all of our documents sealed for 50 years. And these members are selected, and we meet 5 times a year. We elect the Nobel Committee, and this is the voting body of the Prize for Physiology or Medicine, and in just 3 weeks they will be taking the decision. This is the Nobel Committee. This is the working committee. It's like an executive committee. And they do the heavy lifting. A lot of the evaluation of the nominated candidates are done by the Nobel Committee. And the committee is meeting 9 times a year. And the meetings are usually an entire day where several hundred individuals are discussed each year. So let me tell you about a typical Nobel year. And every year we start with a new book of nominated candidates. An individual must be nominated in the year that they would be considered for a Nobel Prize. So if an individual is not nominated, we cannot consider them for example, this year's prize. So they must be nominated. And nominations come in at the end of January, so that's when we start. And we send out thousands of invitations to individuals all around the world. So previous laureates receive an invitation to nominate candidates, the committees and assembly, the Royal Swedish Academies, different academies throughout the world, the National Academy of Sciences, EMBO, etc., professors of medical institutes in the Nordic countries, deans of medicine faculties throughout the world are invited to nominate. And I would say that if you get an opportunity to nominate, you should do it. Oftentimes we send a letter to an individual to nominate and we don't always get an answer back. So we really want the world's input into this process. So when the nominations come in, and again, we are getting hundreds of individuals nominated, about 25% of the applicants or nominations are people we've never seen before. So we really have to dive in and look and see who are these individuals, what discovery are they nominated for, and are they really the person that could be attributed to that discovery? 75% of the individuals are people that have been nominated at one time or another previously, and so we really follow their work. And we watch to see whether or not their research has changed the way we think about the field today. Is it a discovery? Has it changed the paradigm? Has it brought us new insight? And we commission reports from individuals within the assembly, but also throughout the whole world, because we want experts' opinions to help us. But at the end of the day, we are the ones that take the decision. And that voting is, again, the first Monday in October. And so this is a little bit about the room that we're in. So we have a special room where we have double doors, so it's almost a silent room. And we have, the committee sits around this round table where we can have a very active dialogue, and debates will go on for hours. And the entire assembly meets there and will vote by paper ballot. Okay, so after we take the vote, what happens? Well, we usually meet that morning, first Monday of October, 9 o'clock, we make our votes. Well, then we need to let the world know that the candidates have won the prize. So here's some reflections about that process. What happens after we've taken our vote? Well, one of the first things we have to do, we need to find these individuals because our process has been secret. These individuals generally, and for the most part, do not know that they have been nominated. They don't know that they've been under consideration, and they're not expecting a telephone call. And so this is a photograph of Göran Hansen, and he is up here, and it's probably around 10:30 on a Monday in 2013, where he is trying to ring James Rothman, who received the Nobel Prize in 2013 for their discoveries of the machinery regulating vesicle traffic, a transport system in the cell. And what I can say was that I was chairing the committee that year, and one of my responsibilities was to find this guy's telephone number. And with a name like James Rothman, it's not such an unusual name, it's a relatively common name. I had to be darn sure we got the right guy, because it actually has happened that our secretaries have called the wrong person. So you want to make sure you get the right person, because when you call them, you say, you know, Professor Rothman, I'm calling to tell you from Sweden that you have received this year's Nobel Prize in Physiology or Medicine. And you don't want to get the wrong James Rothman, and it actually happened one year with one laureate. All right, so then, as soon as we get in contact with the laureates, and we hope that we can, but sometimes we are not able to do that. But we have a press conference scheduled for around 11 o'clock that same day, and that's where we announce to the world who the laureates are, and we tell the world about their discoveries and the impact of their science. And so this is Mai-Britt Moser, and this is her glee in learning that she's received the Nobel Prize. This was 2014. And it didn't take her long to find a bottle of champagne and start dancing in the hallways. And that's actually me talking about her discoveries and telling the world how phenomenal their work is on the inner GPS. And Mai-Britt is simultaneously, yeah, that's right. Okay, so many of you are students and even faculty. We all think about the Nobel Prize. It's actually not Nobel Prize, it's pronounced Nobel Prize. So here are some tips on how you might become a Nobel laureate in physiology or medicine. So let's run through these. So it's important, as I said earlier, to make a discovery. Again, it's not a lifetime achievement award. You need to be prepared to fight dogmas. I mentioned earlier that oftentimes the laureates are bringing forward a discovery that completely changes the way that we thought about a problem. And if you're doing that, oftentimes you're met with resistance from the field. Oftentimes people don't want to see a change of ideas, but as we heard earlier, we need to present evidence and data and facts to be able to establish a new dogma. There's no real requirement to publish in high-profile journals. Many people are excited about chasing after what we call high-impact journals. But some of the work has been published in very narrow fields and specialty journals, and that work has turned out to have broad implications for human health. So Nobel Assembly is really interested in identifying the discoverer, irrespective of the journal or what language the journal's published in. Sometimes it does help to train in excellent labs, learning the rigorous techniques, learning how to think rigorously, critically. The environment does matter, and I think that the Vice Chancellor talked a lot about environments, and I think he would agree that environments are important for cultivating talent. And your background, where you come from, what part of the world you come from, whether you're male or female, is completely irrelevant. It does not matter. All that matters is the one thing Nobel has asked us to look for, and that is a discovery. And one should be patient, because it can take decades before a discovery is made until we understand the impact of that discovery, and then it is recognized with an award. So let me give you a couple examples. These two gentlemen, they received the Nobel Prize in 2005. This was Barry Marshall and Robin Warren, and they received it for the discovery of the bacteria Helicobacter pylori and its role in gastritis and peptic ulcers. And they fought dogma. Before, it was believed that stomach ulcers were caused from stress and spicy food. How many people have heard that? Have you heard that? It's just not true. It's caused by this bacteria. So they fought dogma, and because of their work, we understand now that the treatments that were conventionally used were not correct, and we have a new way of treating stomach ulcers. I mentioned train in excellent labs, and this is just a few examples, but this is some examples of intellectual pedigrees where a Nobel laureate has trained with a previous laureate. So we have Krebs and Warburg, Thomas Sudoff and Mike Brown and Joe Goldstein, Sutherland and Corys. I used some examples from the medicine field. Another example of pedigrees are biological or married pedigrees, so father, son, mother, daughter, or husband and wife. And we've got some examples of the Braggs, the Borgs, and the Kornbergs, so that would be father-son examples. Mother-daughter is Marie and Irene Curie, but we also have married couples, Marie and Pierre Curie, Carl and Gertie Cordy, Irene and Frederick Jollet, and we have the Mosers we mentioned as well. So sometimes it's good to be a pair. And the Nobel Committee does recognize that, but what we do look to see is that every individual has made a contribution to the discovery. And if we cannot assign the discovery to an individual, we're not able to award that individual. So I can be sure that all of these couples have been vetted for their individual contributions to the discovery. All right, so I said personal background is irrelevant, and I love Jeff Hall. He received the Nobel Prize in 2017 as an example of what I would call an unconventional scientist. And does that guy look like one of your professors? Does he? He's brilliant. He's just a brilliant guy, and a Harley-Davidson fan. But he received the Nobel Prize for discoveries related to the molecular machinery that's controlling our circadian rhythms. And he was working with fruit flies. And this is a picture of Jeff Hall when he came to Stockholm. They are in Stockholm for a whole week before they get the prize. And they have an attaché, and the attaché helps them get to know the city better and see some of the society. And Jeff wanted to go to the ABBA Museum, he was really interested in ABBA music. And when he gave his Nobel lecture, he had on his Harley hat. And he's a great example of someone who, in my mind, is really unconventional, but a brilliant scientist and made important discoveries that have affected the way that we see our biology and physiology. Here's another example. I said, be patient, it can take time. And this is Tu Youyou. And in 2015, she received the Nobel Prize for discoveries concerning malaria treatments. And this is a picture up here of Tu Youyou delivering her Nobel Prize lecture, and she delivered it in Chinese. And this gentleman here is her son-in-law who helped with the translations. And she was elderly and sat down when she gave the lecture, and Jan Anderson, one of the members of the committee, helped her hold the microphone. And when she came, she said to me, I said to her, Tu Youyou, we're really looking forward to hearing your lecture. And this is really the first time we see these laureates. And what she said to me was, I don't have anything new to say. The work is so old, it's so old, she said. And I said, but that's exactly what we want to hear, your seminal work that led to the prize. And indeed, her work was done several decades before the prize was awarded. So be patient. Sometimes it takes decades. Okay, I often get asked the question, Julian, when will there be more women receiving the Nobel Prize? And what I can say, if you look at this chart, this is charting Nobel laureates, women Nobel laureates from 1901 to 20. Compared to the last century. And although I can't predict who will receive Nobel Prizes, I just anticipate, based on the fact that so many more women are going into science, that there will be many, many more women in the future receiving recognition for their work. This is the medicine, and again, it's an example of the females that have received the Nobel Prize. And in the first century, there were 6 women, but only in the last 18 years, again, there's 6 women that have been awarded. So we see great changes already. All right, so coming towards the end of this lecture, and I want to tell you how we communicate information about the prizes each year. And one of the responsibilities of the committee is to write down press releases because we are the scientific experts, provide facts and information for teachers, for scientists, and for citizens about these prizes. And so one way we do that is in the form of a press release. And these are on the website, nobelprize.org, and they're wonderful, wonderful tools to quickly read about the prize. The other thing we do is we provide a more technical document. We call that scientific or advanced background, where we write on a real high-level scientific language the experiments that went into the work that was awarded. And that's really wonderful for students, PhD students, to read much more about what the Nobel Committee and Assembly actually awarded. What were the experiments that were critical behind this discovery? And then the last way that we communicate, on paper at least, is this poster. And these posters are wonderful tools for the schools And I believe they can be accessed and they can be requested from the Nobel Committee and Nobel Assembly. If not, one can easily access them from the website. But this is a wonderful visual that you can put in the classrooms. And we do also have Twitter, and we have Instagram and Facebook and other ways that we can communicate information about the prizes and the laureates. So I'm going to leave you with this, and if you're interested to learn more, again, I focused on medicine or physiology, but if you're interested in learning about economics or literature, peace, chemistry, physics, go to the website, and there's so much to learn. And if you're interested in who was nominated, again, I said we have an embargo for 50 years, but you can actually go back 51 years ago, and you can query who was nominated for the Physics Prize, who was nominated for the Medicine Prize. And you can start to, after 50 years, and today, you can learn about laureates that were awarded in the early 1960s. So go into that. You might be surprised at what you see. And I'll finish here with the same thing I said yesterday. Nobel laureates are coming from the entire world, and, you know, perhaps one amongst you may be a future Nobel laureate. So thank you for your attention, and thanks for the day.
Thank you, Professor Serrat, for your insights on Alfred Nobel, on the Nobel Prize, and specifically on the Nobel Prize in Physiology or Medicine. I would like to open the floor for a few questions. I would like to actually see a female. Oh, perfect. There you are.
A very good afternoon. My question is actually about an inquiry how you explained you opened actually the closed doors, how the Nobel laureates are being chosen. And my question about Dr. Gurdev Singh Khush is that he was a breeder, and he enlarged and improved global supply of rice during the time when there was an exponential population growth. And my question, it's a like inquisition that he wasn't honored with this Nobel Prize. Was the reason that agriculture wasn't mentioned in the fields by the Alfred Nobel, or his achievement was not to the stand that he was achievable for this Nobel Prize? Thank you.
All right, that's a great question. So we actually have sort of a code of ethics in that we never talk about individuals who are not awarded the Nobel Prize. We only talk about individuals who are awarded the prizes. And so I can only comment, and in my case, about individuals who are already awarded Nobel Prizes in physiology or medicine. And you could see from my lecture, I didn't talk about the future. And I didn't talk about individuals who may or may not have been nominated, because I'm not allowed to do that. And only after 50 years can you go to the database and you'll get the answer to your question. So I can't answer that, but time will tell for you.
Hello,
excuse me, ma'am.
Yeah, in the back.
First of all, good afternoon. My question is, there are many peoples who nominated many times, like M.K. Gandhi, Mahatma Gandhi, father of nation of India. I think he nominated 4 or 5 times, but didn't give a Nobel Prize. Why?
So.
Ma'am, there are many...
I think, listen, that's a really great question, and it's very common that we will be asked questions about why an individual didn't receive a prize, and we are really not allowed to answer that. And in fact, if I did answer that, they would fire me from the Nobel Committee. It's true, am I right? And they would all see that, so I couldn't even pretend I didn't say it. So I'm really sorry, but I can't answer that question.
Okay, well, I can understand.
But after 50 years, you will be able to have the answer to that. And I can't see you so well, but you look like you could probably make that 50-year deadline. So.
Okay, we'll give it a shot with a final answer. And
A
final question and a final answer. A question that can be answered. Let me see.
A very good afternoon, ma'am.
Oh, there you go.
This is Shreya from Garvasu. I have a question that we have a large gathering of students over here. what trait as student you cherished at the time that got you at this very stage, and something that we can imbibe in our personality, because I prefer to look at a positive side.
That question I can answer. Thank you. I think it's, all right, first of all, I think it's really important to have a wide knowledge base. And I'll use the example here. I said, I'm a diabetes researcher, and we last year awarded a prize in cancer biology. And so it's important to have a wide base and a large interest. That's one. In terms of getting forward in your career, I would just say, keep positive. Oftentimes we have some defeat that faces us, and that one should really move beyond that. So I would say keep an open spirit and an open mind, and continue learning your whole life, because you'll never get to a point where you say, I know enough. There's always more to learn. You want the Vice Chancellor or no?
Thank you. Mr. Vice Chancellor, yes, please.
Very good that students are asking questions. I'm really very happy. I'm very happy that students are asking questions. But I will help you in explaining something about Dr. Khush. I'm not in Nobel Committee, so I can. Yeah, in medicine or physiology, large number of Nobel Prizes, not Nobel, to geneticists. I'm from genetics and plant breeding. And Dr. PAU, who is responsible for Green Revolution, he also got Peace Prize. And so please make that distinction between discovery, improvement, etc. So that's the reason. Similarly, but I have one question to you or to Professor Harush. This society is moving, it's a little bit longer question, sir. Society is moving toward privatization. Research is moving from public private institutions, and in private sector, I will not be that open. It's fine now. I will not be that open. As I told earlier, I am from I work in the field of genetics and plant breeding. I have seen articles by well-known male geneticists and breeders in American journals. In fact, it is not what is happening. I think Dr. Aslam, nazar lati to. मेरे को बैठे कह रहे कि बहुत सोना चल रहा. Sorry, I shifted because I cannot translate in English quickly. Yeah, I have seen articles in American journals, well-known plant breeding and genetics journals, that I am writing this thing after 20 years or so because of proprietary reasons, and that is definitely affecting science. Do we have some solutions for that? No, very, very difficult. Certain questions don't have the answer, as gentleman asked about Gandhiji also. Such questions should not be put, that's what I feel.
Yeah,
but this is about science.
I'm a generalist, so I think what you're concerned about is that people who are trying to innovate may not disclose their invention or their discovery because they want to protect their patent space. I think that's an individual's prerogative, and it really is. I would also say, though, patent literature is something the Nobel Committee could read. So if it's in a patent, we can read it. If you don't take the patent out, then nobody in the world knows about it, and part of the responsibility is communicating somehow what you've done. And so it's hard for a Nobel Committee to assemble
hand to Professor Julian Serrat. And once again, thank you all for joining us during this session. Thank you again for Punjab Agricultural University for hosting us today. It's been a real pleasure. And I see you, some of you students, this afternoon for the roundtables. Thank you so much.
Thanks a lot, Ms. Laura, for conducting this session of two presentations from Nobel laureates. Now we are to felicitate our two speakers and the guests. Ms. Julian said this talk is about future, reflections from the behind. Who knows, the next, in years to come, we have the next Nobel laureate sitting in this auditorium from the schools we have, the young scientist mind we have from different institutes. Let us clap for the scientific community to have this series in Punjab Agriculture University, Ludhiana. And before we go for the felicitation, I would like to have the standing ovation to these two laureates for their scientific hard work they have put in their laboratories for the years. So let us put our hands together for a big round of applause to these two laureates. To do the felicitation, I request the Honorable Vice Chancellor, Punjab Agriculture University, please come on the stage. And Director Research, Dr. Bans, Dean Postgraduate Studies, Dr. Mrs. Sangha. So first we would like to honor Professor Serge Haroche. And I request Dr. Rishi, please escort Dr. Haroche, Professor Haroche to the stage. Now we call upon Professor Julian Serrat. Dr. Rishi, please escort Professor Julian Serrat. We would like to honor Mr. Klaas Molin, Ambassador Sweden in India. Mr. Klaas Molin. Ms. Laura Sprashma, CEO of Nobel Media. Ms. Erika Lena, CEO, Nobel Prize Museum. And now the Secretary, the Department of Biotechnology, Dr. Renu Swarup. Dr. Muhammad Aslam, Advisor, Department of Biotechnology, Government of India. So once again, we are thankful to all the Nobel laureates and the Nobel team. Thank you very much, sir, for honoring the dignitaries. Yes. Sorry, I missed one. Dr. Tia Sharma, Director, National Agri-Food Biotechnology Institute, Mohali, Nabi, because they are the co-host for this event also. Dr. Tia Sharma, please. So one felicitation we have for the guest, the better half of Nobel laureate, Madam Horsey, because the motivation which we get from the home while working in the laboratory. We request, please come on the stage. So I request Dr. Rishi, please escort. Okay.
Picture.
Yes. So
on stage.
Can you put it yeah. Huh? So this is the real motivation which we get from the home. Now I request all the dignitaries, please come on the stage for a common group photograph. Sorry to bother you, please. I request all the dignitaries come on the stage for a group photograph with the guests and the Nobel laureates. So I have a few announcements. Like after this session, we will have interaction with the press media. The Nobel team will be having this interaction, closed door interaction. In the meantime, the guests all are requested to join us for the lunch in Sukhdev Singh Bhavan, and there is an exhibition upstairs also. So do visit that exhibition also. Thank you very much, sir. I request all the students, those who are to participate in one-to-one interaction with the Nobel laureates, please assemble at the respective venues at 3 o'clock. Please stay back for the national anthem. Yeah. Please stay back for the national anthem. Yeah. Yes. Now start, please.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उत्कल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you very much. So then one-to-one student interaction will be at 3 o'clock in the respective auditoriums, venues. I request the students, nominated students, stay here for that one-to-one interaction.